Hello everyone. In this presentation, we will talk about data movement in the context of the FAS Research Computing Cluster. When moving data onto, off of, or within the FASRC cluster, there are many factors involved in achieving the most efficient transfer. Some of these factors will need to be considered concurrently as they depend on each other, but we will focus on them one at a time at first. Later, we will go over some specific examples so that we can understand how they work together. The first step in determining the best data transfer method to a particular storage system is to identify the location of that storage. The location of both the source and of the destination will affect the method of transfer because each location has its own unique set of network connections and access nodes. Access nodes are the specific nodes through which you can reach the storage. And some storage destinations may have more than one route to them from your source location. So to choose the best transfer method, you need to consider all the possible routes to that storage destination, and we will show you how to do that in this presentation. The FAS-RC cluster has two primary data centers. First, the Massachusetts Green High Performance Computing Center, or MGH-PCC, in Holyoke, Mass., commonly referred to as the Holyoke Data Center. And second, the Markley Data Center at Summer Street in Boston, Mass., commonly referred to as the Boston or Summer Street Data Center. Holyoke houses all of the cluster's compute nodes, the Holyoke login nodes, and the global Scratch storage. The Boston Data Center houses the Boston login nodes, a majority of the lab storage, and all home directories. Each data center also has its own Globus endpoint. We will talk more about Globus in a moment. Any storage devices that have BOSS or Holy in their name are in Boston or Holyoke, respectively. For example, BOSS LFS is in Boston. Any storage devices that do not begin with BOSS or Holy can be presumed to reside in Boston, where most of our lab storage is. In the demo at the end of this presentation, we will show you how to find the IP address of the storage and how to use that to either determine or verify the location. It is also worth noting that if the storage device has LFS in its name, it is a Lustre file system, and we will be talking more about this later. The next step in determining the best transfer method is to find the network route between the source and destination with the highest end-to-end bandwidth for the fastest transfer. To help choose the best network route for your transfer, please refer to the FAS-RC network diagram linked in the slide. As you can see on the slide, the bandwidth sometimes changes between nodes along the network path, and you want to be aware of and avoid the slowest sections of path. For example, referring to the network diagram, to download data from an external site to a Holyoke Lustre system, you could go through a compute node, a login node, or a Globus endpoint. Using the compute nodes would have a greater bottleneck than the login nodes because their connection to the outside world is 1 gigabit per second, whereas the login nodes have a 10 gigabit per second connection to the world. The Globus endpoints have a 100 gigabit per second connection to the outside world. So in this instance, you would want to go through the Holyoke Globus endpoint, which is preferred, or the login nodes to avoid any 1 gigabit per second networks. If using the login nodes, the Holy login nodes are the better option because they are co-located with the Holyoke Lustre system. Whenever possible, avoid transferring data over Wi-Fi or over the RC VPN as they have the lowest bandwidth of any of the methods mentioned. When determining the path that your data will take from its source to its destination, it will need to pass through a transfer node. The transfer node is the machine that can run the software or service necessary to manage the data transfer. There are three main options for transfer nodes that you can use to move your data: 2 Globus endpoints, 8 login nodes, or a large number of compute nodes. The right transfer node for your individual transfer should fulfill several requirements. It should be along the optimal network route between your source and destination. It should have the software or service needed for the type of transfer you want to do, and it should have access to your storage on the cluster. For instance, to start an SFTP transfer from your desktop to storage on the cluster using FileZilla or a similar SFTP client, you would go through one of our 8 login nodes since they have the SFTP service running on them. If you are transferring data to or from an outside organization that has their own Globus endpoint, then one of our 2 Globus endpoints would be your transfer node. Or if you were to move data from your IB-connected lab storage to the cluster Scratch device, Holy Scratch 01, then a compute node would be your transfer node, in which case you could use the rsync or fpsync tools. Globus is always the preferred method for transferring large amounts of data to or from other organizations since it has the highest bandwidth of any of our transfer nodes. You can also install the Globus Personal Endpoint software on your desktop or laptop to transfer data from there to your storage on the cluster. When Globus is not an option, or for more trivial transfers to and from non-cluster machines, using the login nodes is best. You can use SFTP, SCP, or rsync on the login nodes. Just be sure to choose the login nodes that correspond to the data center where your cluster storage resides. For instance, instead of using login.rc.fas.harvard.edu, which can route you to any one of our 8 login nodes in either Boston or Holyoke, instead use bosslogin.rc.fas.harvard.edu to reach one of the 4 login nodes in Boston, or use holylogin.rc.fas.harvard.edu to reach one of the 4 login nodes in Holyoke. The compute nodes are ideal for certain scenarios as well. If you are transferring data to or from outside the cluster, and you can parallelize the transfer in some way, the large number of compute nodes available on the cluster can be leveraged for a quick transfer. Or if you are moving data between 2 storage devices that both reside on the cluster, you can use fpsync on a compute node. The tools you use to perform the transfer are often dictated by the route you have determined or the transfer nodes you will go through. If the route you have chosen is far superior to any secondary options, or if it is the only route possible, then you may be limited to the transfer tools available for that route. But if your route affords you multiple options for transfer tools, you can pick one based on the options it offers. Globus has the fastest connection to the outside world from the FASRC cluster via Internet 2, but it can only be used to transfer to and from other organizations that also have Globus endpoints, or between the 2 FASRC data centers. rsync will transfer only the files that are not the same at the source and destination, so you can easily keep data at 2 locations synchronized. This is useful when you only want to transfer files that have changed, and it is also useful on unreliable connections, since retrying a failed transfer will pick up where it left off rather than starting again from the beginning. fpsync allows multi-process transfers, so it's like a parallel version of rsync, but allows for faster transfers than rsync alone. This should be used on compute nodes only, not on login nodes which have limited CPU resources. SCP, unlike rsync and fpsync, does not offer synchronization. It is primarily used for one-time transfers, but it is fast and simple. SFTP does not offer synchronization either, so its primary use is also one-time transfers. It is sometimes slower than SCP, but it offers more functionality, including commands that make remote file manipulation possible, such as creating directories or removing files remotely. Samba is the protocol that allows you to access your cluster storage from your desktop or laptop. Though it can be used for bulk data transfers, it should only be considered as a last resort. It is not as fully featured as other options, it is not always compatible with advanced file permissions, and it requires you to be on the VPN, which provides the slowest connection. I mention Samba only because it is the only option available to people who have an FASRC account but do not have cluster access. In this video, we will go through a couple of common scenarios to demonstrate how to move data on the FASRC cluster using what was taught in the data movement video. For scenario 1, we are going to transfer data from our laptop to the J Harvard Lab storage. We know the source is our laptop, but let's find where the destination resides. Logging into a cluster login node, we can run df/jharvard_lab to see which storage device it lives on. Because it lives on a Lustre storage system, df shows the IP address and name of the system in its output. For comparison, let's look at the output of the df for storage that lives on a non-Lustre system. It shows the name of the system but no IP address. So we need to use another command, nslookup, to get the IP address. Remember that we are using the IP address to find the data center of the storage system. Systems whose IPs begin with 10.242 are in Boston, and any IP that begins with 10.31 is in Holyoke. Next, we find the network path. There are multiple paths from outside the cluster to BOSS LFS. You can think of your laptop as being in one of the clouds on the network diagram because it is connected to the internet outside the FASRC cluster. Right away, we can eliminate the clouds that connect directly to Holyoke since we are transferring to a storage system in Boston. So the three viable options are through the BOSS login nodes, the Globus endpoint, or the Samba cluster. As mentioned previously, to connect to the Samba cluster, you have to be on the VPN, which is the biggest bottleneck, so we will disregard that option. The BOSS login nodes and the Globus endpoint both have similar network paths to the Boston Lustre system, BOSS LFS. The bottleneck on each is the 10 gigabit connection to the BOSS LNet router, so either one would be a good option. Now we will pick a transfer node. Since the network paths from Globus to BOSS LFS and from BOSS login to BOSS LFS are similar, Globus or BOSS login would be our potential transfer nodes. For this example, we will use the BOSS login nodes as our transfer nodes, though you could just as easily choose Globus. Finally, we will choose the software to use. Since we have chosen BOSS login to be the transfer node for this transfer, we can use any of the tools available on the login nodes. rsync, SCP, and SFTP are all available on the login nodes. We would not recommend fpsync on a login node, as the login nodes are not intended for programs that utilize large amounts of CPU resources. That's what the compute nodes are for. So we will choose the next best option for us, rsync, since rsync can pick up where it left off in the case of a dropped network connection. So our transfer command on a Unix-like laptop, Linux, or Mac OS X, for example, will look like the following. rsync-r, the source on our laptop, and then the destination connection string consisting of the username and node name, followed by the destination path. The R is the recursive option and tells rsync to synchronize the given directory and all files and directories within it. If we are on a laptop that doesn't have rsync, such as a Windows PC, the next best option would be SFTP. For this, we could use an SFTP graphical client like FileZilla. Since FileZilla is documented thoroughly on our website, I won't go into the details here. Or you could use a third-party command line client, such as PSFTP, from the makers of the PuTTY SSH client. For scenario 2, we are going to transfer data from that same J Harvard Lab share to the cluster's global Scratch storage system, Holy Scratch 01. We already located the source of the transfer in the previous example. It's on BOS LFS, the Boston Luster file system. Even though we can see from its name, Holy Scratch 01, that the Scratch file system is in Holyoke, I will go through the steps of verifying that one more time. We do a df on /n/holyscratch01, which gives us an IP, and we can see that the IP is in the 10.31 range, which denotes Holyoke. For the network path, we see that there are three main routes to get us from the Boston Luster file system to the Holyoke Scratch file system. We can go through the Boston login nodes, the Holyoke compute nodes, or the Globus endpoints. Notice that the Holyoke compute nodes only have a 1 gigabit per second connection to the Boston network via BOS LNet, whereas the Boston login nodes have a 10 gigabit per second connection to Holyoke via Canon LNet. So the Boston login nodes are better than the Holyoke compute nodes for this transfer. But better yet might be the Globus endpoints. They have a 100 gigabit per second connection between the data centers via Internet 2. Even though the bottleneck in that route will be the 10 gigabit per second connection from the Globus endpoints to the routers, it may still be faster overall. If you prefer to use Globus, I would direct you to our documentation to get started. So in this demonstration, we will use the BOS login nodes, and that gives us several options for tools. We could use rsync, SCP, or SFTP. In this example, there are no requirements for the advanced features of SFTP, so I would suggest rsync, since it is more robust than SCP. So our transfer command would look something like the following: rsync-r, the source directory, and the destination directory. This concludes our demonstration. For more information on this topic, please visit our documentation site, docs.rc.fas.harvard.edu.